Hello, everyone. Hope you can hear me correctly. I want to welcome you to this last session of the day. Hopefully you have some energy left in you so that we can talk about VMware Tanzu Application Platform. My name is not Oded Chopin. Unfortunately, my colleague couldn't come because of the medical reasons. My name is Bruno Šunjić. I'm a core solution engineer sitting in Zagreb. And with the help of Oded's recording, I think that we will have a nice presentation for you. For starters, just welcome from Oded. Oh.
As a solution engineer at VMware. Unfortunately, I couldn't be with you in person this year. COVID got the best of me, as you might be able to hear, so I'll have to deliver this session remotely. Thankfully, I have Bruno here with me, taking the lead on stage, so let's get started.
Yeah, let's get started. So some of you might know VMware, we weren't strong in the development application world, but as there are more and more applications, we focused on that. And as we acquired Pivotal, we provided some new solutions to the market. One of them is the Tanzu Application Platform, which we will talk about today. And there are also infrastructure solutions for running Kubernetes. So Kubernetes is incredibly easy, isn't it? Yeah, you bet it is. So there are, what we saw from a lot of surveys in the market, that customers that invest in velocity of their developers have much more revenue growth, much better, they are more innovative, and their developers are more productive. So that's the problem with Kubernetes. They are killing your developers because of the complexity, because of a lot of features and options and things that you need to set up. And a lot of software teams are unnecessarily slow in deploying their codes and their solution because of those issues with Kubernetes. So it's not just building your code and deploying it. You need to work out networking, you need to work out security, and all that stuff that the developer really doesn't want to do. So this is where Tanzu Application Platform comes into place. The idea is to unlock your developers' productivity, to help them do their business easier, and build a sustainable path to production. You will see later our path that helps the customers, developers, to deploy their application easier. And also coordinate the work of many teams that are involved in application lifecycle. So when we look at that path, we split it in two loops. The inner loop, the development part, where you do your coding, where you do your testing and debugging of your code. And once it's finished, we move to the other outer loop, where you have DevSecOps team that needs to validate that, package the code, deploy it on the infrastructure, and then secure it and make sure it is accessible. So for starters, let's focus on the inner loop. We have a simple application, to-do application, which is partly on Postgres and Node.js. And let's hear Oded's recording about what TAP can offer.
So the first thing that we're seeing when using Tanzu Application Platform is TAP GUI, which I have here running on an EKS cluster. And TAP GUI is based on the Backstage project from Spotify, which is basically a developer portal that really enhances the experience for developers to be onboarded very quickly. There's a very long list of plugins that you connect to this project if you'd like. And we are contributing our own enterprise-ready plugins as well to make it much more production-ready, as we will see down the line. So as you can see, I have multiple microservices here from multiple teams. and multiple microservices are grouped into systems, which can be thought of as a big A application consisting of multiple microservices. But now I want to start and create my own new application. So for that, I'm going to go to the Create tab. And as you can see here, I have multiple basically accelerators or templates available for me out of the box. Now, these are templates that you can customize and create your own, and these are just basically suggested starting points. Behind each one of these rectangles is a Git repository, and in this Git repository, we have a file called accelerator YAML, where every component in this YAML represents a GUI in the UI, like this Java dropdown here represents the dropdown here. If I click choose, and I can see the dropdown available here. So basically, this is how a developer can customize the starting point of an application based on the guardrails that an architect in the organization might allow him to have access to. So I'm going to use a different project that I already started right here, just for the sake of time. And as you can see here, I have various files already configured. And this is my main application of Spring. Nothing really special here at the moment. So let's start developing our application. So I want to create an entity to represent our to-dos application. So I'm going to declare an entity, and I'm going to give it an ID and a title and a Boolean indicating whether it was completed or not. And once I have an entity, I can use a repository REST controller in Spring to basically expose this entity via various CRUD operations, create, update, delete, retrieve, etc., using just a simple JPA repository. So I'm going to add that as well. And I also want to have some things happening just before a save occurs in my application. So I'm going to add a repository event handler, and I'm going to say whenever there's a save activity, before that, just log some items into the log, basically saying an application or a task is completed, to be exact, right? So this is my application, fairly simple, fairly straightforward, and this is really all I wanted to do in order to make sure that it works. So I'm just going to right-click and say Run Java, right? By running my application on my machine before even moving to Kubernetes, as you usually would. Okay, and it seems to be running well. Let's see if it works. So I'm going to use HTTP, and I'm going to call 8080/todos, and I get an empty list as expected. Excellent. So my application works, it appears, and it works on my laptop, but as we know, this doesn't really mean much. What I really wanted to do is to work the same way, but in the context of Kubernetes. So for that, I'm going to take the same application, and I'm going to run it now in Kubernetes. So for that, as you might recall, I have a workload YAML generated as part of that accelerator that the platform gave me. And in here, really, I have just the basic information that I'm expected to have about this application. For example, it's a web application, it has a test, it's part of the larger to-dos app application. I override the version of the JVM I want to use, and I provided the endpoint where my Git repository exists. Now, at this point, even before I have my Git repository committed, I want to test it locally, but in the context of Kubernetes, running remotely. So I'm currently connected to a cluster on GKE called Iterate cluster. And this Iterate cluster basically gives each developer his own namespace, kind of like a playground to check his code and make sure everything works as expected. So all I have to do to check this application in the context of a Kubernetes cluster is right-click this tilt file that was generated as well, and just click Live Update Start. And what's going to happen now is the application, or the platform to be exact, is going to take my existing source code on my machine. It's going to upload it to a remote registry, make a production runtime image out of it, and once that's complete, deploy it to this Iterate cluster using Knative serverless runtime. So all of this is going to take a couple of seconds. As you can see, we are using the Cloud Native Buildpacks technology here in order to basically build this image automatically without any need for Docker files or anything like that. It just looks at our source code, understands what is written, and knows how to build a production-ready image out of it automatically. And it saved the image to my remote registry. It added cache layers to each one of the layers that are relevant for caching. So as you can see, our Spring application is now booting up remotely on this remote cluster. And we can go ahead and start testing it now. So before I do that, let's make sure everything works as expected. So let's again do workload get for this workload. And here is a remote URL that I received. And this works. I can just open it in my browser. And I can run the to-dos endpoint just like before, and I can see it works. But also because I'm currently running in this iterate cluster for iterative development, I also get an endpoint locally on my own machine. So if I go through the same URL, but going to localhost, I'm going to get the same endpoint. This is basically SSH tunneling to that remote Kubernetes cluster. And I can run the exact same APIs as before. So let's see if it works remotely as well. So again, I'm going to go to 8080 to-dos, and I'm going to say title equals get milk. And it gives me confirmation that it works under this endpoint. So I'm going to basically request this as well. And I see that it works as expected. Excellent. So things definitely work exactly as I would have liked. If I go back to the tap GUI, and I'm going to go here under the same component that we just deployed called to do service, I'm going to see all kinds of information. I'm going to see things like the dependencies or where the source code will be eventually. And there's also this runtime resources endpoint, which is very interesting. So here I'm going to see all of the Knative services in all the clusters that I have related to this application. As you can see, I already have a version of this application in the production cluster and in the test cluster. And right now I'm working on the iterate cluster, which was created just 3 minutes ago, right? So if I click here, I'm going to see a lot of information about my application. I see the endpoint. I can see the YAML that was generated for me, which I didn't have to write, which is always great. Down the line here, I see the pods that were generated for this application. And if I'll go to one of them, I can see here information that is related to my application itself, to my Spring application, and not to the pod or the Kubernetes layer. Things like what environment variables my application currently sees. Things like threads. What is the current threads that my application is currently running or waiting on, or timing out, etc. Similarly for memory, I can see the heap memory and the non-heap memory. I can even see the various HTTP requests that were sent to my application and get a drill down information on each one of them to understand the request and the response.
Okay. So what if you need to debug your code or change something? Well, how can TAP help you then? Let's see on another video.
Now, there's something very interesting that I see here when I perform a put operation. For example, let's update entry number 1 and say that I want to mark the status to completed, right? So I do this, and I see that it is completed as expected. However, I'm not seeing any entries in my IDE reflecting the change, right? So in my logs, let's make it a bit smaller. I don't see any of the logs that I currently have set up in my application. So one of the great things we can do when using the platform is actually to start remote debugging just like I would have if I were running locally. So in order to do debugging, obviously I need to mark some breakpoints. Let's put 2 of these here. And all I have to do is basically go to my workload and just say Java debug start. And this is going to set up a separate endpoint that's going to connect to my main endpoint. And it's going to start debugging, a remote debugging session for me against my remote pod. So this is going to take a couple of seconds, and then we can try again. And as you can see, we now have this orange bar indicating that debugging has begun. So let's try to test our application again. So once again, let's change it to false, enter, and we get no breakpoint. That's very interesting. Why not? So obviously something is wrong here. And what is wrong in this case is that I just forgot to add a component annotation to my application here. And it wasn't configured correctly. Now here's a very interesting thing. If you take a look here, once I'm going to click save, what's going to happen is it's basically going to take the existing code in the remote pod and update it live. Basically do a live update without me having to do a full rebuild and redeploy. So I'm going to hit save, and it says, hey, to-do repository has changed. I'm going to copy that class over to the remote pod, restart the application, and now my application is up and running again. Didn't have to do this whole 2-minute redeploy process all over again. So once again, if I'm trying to set it to false, and it seems we are blocking on debugging, and here's our debugging. And now we can see that we hit the breakpoint, and we can see that we have info being logged, and we have additional information logged into our application. So things appear to be running exactly as expected, which is great. And there is one more thing that kind of bugs me here. So as you can see, if I run this at the moment, I get an entry. But if I delete this pod, then a new one is going to be created in its place. So the new application is now up and running, the new pod to be exact. However, now I lost all of my data. I don't have anything. I don't have any to-dos. They're not there. And the reason for that is that by default, our application is provisioned to use either HSQLDB, or if it has connectivity to Postgres, then it would connect to Postgres, but we did not set up any connectivity yet. Our application properties don't have any reference to a Postgres database. Now, the nice thing about Tanzu Application Platform is that I don't have to really manage all of these URLs and usernames and passwords and all of that. I can just get a claim, just like a persistent volume claim, into a service that maybe my DevOps engineer or my platform operator provisioned for me. So I'm just going to add that into my workload YAML here, and I'm going to add it as a service claim. So basically what I have now, let's move the debugger. What I have now is basically a claim on a database, which was provisioned ahead of time. And there's no reference here to where the database might live. It might even be in a different cluster for all I know. All I know is just I have its name and its resource claim kind. If we'll try to run our application again, and if we'll have a look here, we should see that this time, now when the application starts, we're actually using Postgres instead of HSQLDB, and our application should be connected to the database. And again, I didn't have to provide any application properties entries or anything like that. I'm gonna create my entry again. And as you can see, I have my entry available. And as you can see, I already played with this database in the past, and I already have 26 previous entries here. And if I delete the pod, there it is. So I should be able to have the exact same information being returned, which I do. Excellent. All right, so I think this is good. I think we can commit our code and move on to the next task. So I'm just going to do a git add. I'm going to commit my code. I'm going to push it. And I'm done. I'm going to move on to the next task and work with it. So now let's switch hats and basically move to the outer loop where the DevOps team takes charge.
Okay, as Oded said, now we're finished with the inner loop. And let's switch to the outer loop, to the part that DevSecOps team need to test and build, prepare the containers, and run it on the infrastructure. So for that part, Tanzu Application Platform prepares pipelines and all the tooling needed for this application to for you to easily deploy this application. We have strong sets of default applications in this pathway, but also you can bring your favorite tools and integrate them in the pipeline. Now let's look how this DevSecOps part.
So now we'd like our application operator to take the code that the developer just committed and run it through a supply chain to make sure that the code is compliant, secured, and ready to be deployed to our staging and production environments. So let's see how Tanzu Application Platform helps with that. So for that, we're going to move to a different cluster. This one is running on EKS. And I'm going to use a central build cluster to manage all of my supply chains. I'm going to do Tanzu apps workload create. I'm going to reference this YAML file that the developer gave me. And this is, again, all the information that the developer knew, the web application type, the version of the JVM, the resource claim for the to-dos database, and where the source code was pushed. So I'm going to say yes, and it says, okay, you can go ahead and review the information right here using a tail command. But I can also go back to my supply chain dashboard here, and I'm going to have a look at what goes on here. So there's a new entry now for to-do service, which is basically running a different type of supply chain in this cluster called test scan to URL. So let's see what that does. So it begins by pulling the information from the Git repository using fluxcd. And next, it's going to run unit tests for us. So it's going to make sure that our code runs as expected. And I can see the logs here and make sure there are no surprises. And once that is done, we're going to move on and it's going to start scanning our code, our source code to be exact, to make sure there are no vulnerabilities at the source code level. Now, while this is running, and as you can see here, I have this entry for the to-do API basically generated for me. And if I go here, I basically have the entire OpenAPI Swagger dashboard that I can use to test my application. I can run various endpoints that I might have and just make sure that everything works exactly as expected. So if I'm going to go ahead and try it out and click execute, it's going to run it and I'm going to get a response entry. Now, another very nice thing about Tanzu Application Platform GUI is the ability to view the hierarchy of the components. So here, for example, I can have a better understanding of how my application looks like. Now I can already see that I have a UI component, which is part of the system, and I have a backend system called to-do service, which exposes the to-do API, and they are both part of the same application. So going back to the supply chain, and we are right here, we can see that our testing finished successfully, but it looks like our source scanner failed, and wow, that's a big error message here. And that's always good that we're getting blocked as early as possible. So let's see what happens here. If we click here, we'll see a lot of critical and high vulnerabilities on PostgreSQL. And these entries, if I'll click on one of them just so we'll better understand what we see here, appear to be related to how the Postgres Java library is acting in certain versions. So after investigating it further, I understand that some of my dependencies are not well enough. So I might want to go ahead and fix that. So I'll go back to my VS Code and I'll go to my POM XML. And under Postgres, I'm just going to upgrade the version of PostgreSQL to a higher version. So I made a change. Let's see if that works. So again, currently I have a new change. I'm going to add it. And I'm going to commit it. And I'm going to push it to my repo. Great. Let's see if that works. So I don't really have to do anything else now. I mean, fluxcd is just going to monitor that a new commit happened just a few seconds ago, and it's going to trigger a new run. The new commit was pulled by fluxcd, and it's going to start running our tests again very, very soon. So once again, we're scanning our source code. Okay, this looks much better. And we moved on to building the actual image. Once I move on, I configure my application. And the last point I have here is basically that the supply chain creates what we call a deliverable, as you can see right here. And this deliverable does not deploy anything to any cluster. The only thing that it does, it really takes the artifact that is ready for run environments and it just saves them in a Git repository. So if I click Review Approvals, we'll see that it created a Git commit for me in a GitOps fashion that I can now deploy to multiple run clusters. So one of these clusters, as you can see, is the iterate cluster, which we already ran multiple tests on. We don't really care about that at the moment. The other one is a production cluster, which we'll get to in the end. And the last one is a test cluster, which we want to test right now. And as we can see here, the last pull from the test cluster was about 3 hours ago. So let's approve our Git pull request so we can deploy to the test environment. So I'm going to click Approve a Request. And this is going to open a pull request window. I'm using GitHub, but it can run on things like GitLab and such. And I'm going to merge this pull request. And once it's done, I can safely delete this dynamic branch which was created. And let's see what happens. So going to my main branch, which is where my test cluster deploys from, I have per microservice its own entry, like to-do service. And here, as you can see, it generated just 2 minutes ago 2 entries. One of them is the delivery YAML, which is just a Knative service that deploys the application for me to this cluster with all kinds of production-ready defaults, such as the correct Java tool options, liveliness probe, readiness probe, and the like, and just making sure everything works as expected. The other part that it provisioned for me was the service claim, which, as you can remember, we're talking to a database, and this database is a Postgres database that we are using in order to connect to our application. So if you go back here to the UI, and we check what happens in this test cluster, so we can see that a few seconds ago, a new pull has been taken from the Git repository, and we get an approval that our application has been successfully deployed. So if I'll go to my endpoint, see my application, and again, hello world, get milk, call mom. Seems to be working as expected. I can mark items as completed. I can delete certain items if I'd like. Wonderful. So what we've seen here is really an end-to-end supply chain, because production really starts from your developer laptop, right? You design your application, you test it, you want to see it in the context of Kubernetes, you want to connect other baking services to it, you want to test it alongside other microservices you might have in your Kubernetes cluster. And once you commit your code, you also want to make sure you have security gates along the way to make sure that only code that really is compliant can go all the way up to production. We've seen that the image scanning portion just worked without any CVE patches, and that's because Cloud Native Buildpacks provides continuous CVE patching for your operating system and for your middleware, such as OpenJDK, .NET Core Runtime, and the likes, automatically out of the box as part of the platform. So I hope you found it interesting, and now back to Bruno for closing remarks. Thank you very, very much for your time.
Yeah. Okay. We even got an error message to wrap it up. So for the end, what do you need? All those steps that we just shown, you need a pathway from those steps. And the application platform is the thing that can provide you that. If you have any questions, please contact my colleague Oded on Twitter, or we can discuss it offline and do a session or whatever if needed.